Yesterday we finished up multiplying and dividing, so now we have to add and subtract.
Yeah.
In order to add and subtract rational expressions, how do we add and subtract fractions?
I don't.
How do we add and subtract fractions?
Do you go across?
No?
Okay. I don't know that.
So, let's see, I didn't really leave a spot for an example, but I'm going to throw one in here. How do I add 1/2 plus 2/3?
You add, what did you say?
Common denominator?
6.
Okay, so you know something about what we're doing here.
Yeah.
Common denominator 6. How do you make this 2 a 6?
You times it by 3.
Times it by 3. So what do you do to the numerator?
You times that by 3.
Times it by 3.
Yep.
Whoops.
Oh.
So then that's going to be
3.
3/6.
6.
Plus?
1/2. Oh,
How do you make 3 a 6?
times by 2.
Times it by 2. So what do you do with 2?
You times by 2.
Times by 2. And this becomes
4 over 6.
4 over 6. 3 over 6 plus 4 over 6 is
7 over 6.
7 over 6, right? Okay. So that's how we add basic fractions. Okay. We need a common denominator. Okay. Sorry. Okay, just let's get it out of the system. Has everyone looked at the last set of examples?
Yeah.
Let's get it out of our system. We won't get to it till Monday.
Yeah. Wow. So you're going to give that to me on a Monday?
I
I'm
am.
not trying to be that guy.
Okay. I caught an expression over here, then I caught an expression back there, and it's hard for me to keep a straight face while I look at you guys like noticing the last 4 examples of the notes. Okay.
Macaroni, cheese, ham, bacon,
Now.
shrimp.
It looks horrible.
Okay.
Those complex fractions look horrible, but I promise they are very doable. Okay? We'll look at our techniques, we'll talk about it, but we won't get to those till Monday. Okay, so we just did 1/2 plus 2/3. Now, okay, let's look at this first set. We would need to add the fractions. X over x plus 4 plus 5 over x plus 4.
5x over x plus 4. Or, wait.
Well, thankfully,
What?
they have the same number.
Yeah, they have the same denominator.
Okay, so good news. They have the same denominator, right? So, like over here, we got the same denominator of 6. We kept the 6, and then we just added the tops, right? Added the numerators. So,
Good to go. Good to go.
nope, we're going to add the tops today. Okay, so we're going to keep the denominator of x plus 4. We're going to add the numerators. What do we get when we add?
X plus 5.
X plus 5 is x plus 5. The only thing you have to ask yourself after that is, can we simplify in any way, shape, or form? And remember, in order to simplify, if you want to simplify, we have to simplify factors, right? So in order to cancel an x plus 4, what else do we need? Another x plus 4. In order to cancel an x plus 5, we need another x plus 5. Can we just cancel these x's? No, we want to, but we can't. That goes back to the previous lesson. So your answer in this particular example is x plus 5 over x plus 4. Now, we're only going to talk about it on this first set, but what can x not equal here? What can x not equal?
Yeah. 5, -4. Oh, it's just negative 4.
Oh, negative.
You can't.
And this
Okay.
is the denominator.
So, if we real quick talk about restrictions on the variable, it's a fraction. Are these restrictions going to be any different from what we did last lesson?
No.
No, it's going to be anything that can make the denominator equal to 0. And so what would make the denominator equal to 0 here? The -4. So restrictions, there's just a couple, literally like maybe 2 or 3 you're asked to do it. It's the same thing as last time in that we're setting the denominator equal to 0. So in this case, it's just x plus 4 equal to 0. So x cannot equal 4. Okay? So I don't know that it ever says restrictions. Oh. Would you prefer me to say x cannot equal -4?
Yeah.
That would make more sense.
Okay. Xander had a really confused look on his face, and that's what clued me off here. If somebody has a really confused look, I'm usually like, okay, what am I doing here? Okay. There's just a couple in homework, and I don't know if they stated them as restrictions on variables, but, you know, if it gives you like an A or B option where you have to state excluded values, you want to pick the one with excluded values today and state what they are. Okay? So B. Thoughts on B?
How in the world are we gonna have that?
Well, does it have a common denominator?
Yeah.
Okay, what's my common denominator?
2x plus 3.
So we're going to put the two fractions together as one.
Alright.
Denominator is 2x plus 3. Then we're going to add the numerators. Now, if you want me to do it the long way for a moment, I'm going to add 10x minus 5 plus 8 minus 4x. However, am I going to leave my answer like that?
No.
You can simplify it
No, we're going to clean up.
6
back to my terms.
Okay,
and 3.
10x minus 4x is
6x.
6x minus 5 plus 8 is plus 3 over 2x plus 3. Okay. One thing you need to be doing when you get to final answers. It won't always make a difference, but we always need to be checking. Is there any factoring I can do here? Because if there's factoring to do, it might lead to canceling. Does 6x plus 3 factor?
It's 3x plus 2, right?
There's a GCF of 3. So if I factor a GCF of 3 out, what remains in my parentheses? 2x plus 1. All over 2x plus 3. Now, by factoring, does anything cancel now? I have a 2x plus 3 on bottom. What do I have to cancel with a 2x plus 3?
A 2x plus 3.
A 2x plus 3. Do I have one?
No.
No.
No. So can anything cancel?
No.
No. Okay, guys. I can't say what Sophos is going to want. I did not think to check into that.
I'll look.
Okay? But, no.
Okay.
What I'm going to say is I personally would accept either of those answers because nothing canceled. Now, if I was going to guess, Sophos might prefer the factored one. So if you don't factor something and Sophos gets mad at you and counts it wrong, try a factored version. Because Sophos might accept both, but if they're not going to accept both, they're going to be looking for the factored one, I'm guessing. Okay?
I bet you're interested.
It wouldn't surprise me. Now, real quick, restrictions on the variable. What can x not equal in this problem?
2x plus 3. Or, I don't know. I don't know what I'm talking about.
I knew what you meant. Set 2x plus 3 equal to 0, and x cannot equal -3/2, right? Because you would subtract the 3 and divide by 2. Okay. What's different about problem C? Subtracting. Okay. So, with it being subtraction. Now, good news, what do we already have?
Same denominator.
Same denominator.
Same denominator is there. So we've got the x plus 5. Now, what you've got to remember is when we are subtracting, we're subtracting everything from the second fraction. One way I can show this is I can say, okay, it's x minus 5 minus, and I'm going to put 3x minus 21 in parentheses as an option of how to show it. But you've got to remember we're subtracting everything in that second parenthesis. Can we subtract in our next step, or would you prefer me to distribute my sign?
I was gonna say we're gonna distribute.
Okay, so one option is we could rewrite it as it's still x minus 5, and then that's going to be minus 3x and
Positive tone.
plus 21. All over x plus 5. And again, do you have to show all these steps necessarily? No, some of you may have done this in a shorter way, and that's fine. What cleans up here?
X plus 5. No, well, that tricked me because
What do we know about x here?
I don't know.
It goes with
Negative 3.
minus 3x. What's 1x minus 3x?
Minus 2x.
Minus 2x. Then we have minus 5 plus 21. What's minus 5 plus 21?
16.
Okay, plus 16. Over x plus 5. Is there any factoring I can do?
Well,
Yeah.
yeah.
Technically, there's a GCF on top. What's my GCF on top?
2.
Negative 2.
I would say negative 2 because my first number is negative. So I would say this is negative 2 times x minus 8 over x plus 5. Does anything cancel? No, it doesn't. So again, I know in my textbook it says either or. I will accept either or. Again, I can't speak on behalf of Savas. I didn't think to check into one of those.
I can check right now.
Nope.
No.
Okay.
No.
Is there any excluded values?
No.
Is there something x cannot equal here?
Oh, wait, yes.
What can x not equal?
Negative 5.
And I kind of filled all my other space, so we're going to write it like that.
Oh gosh, I don't have any room. Alright.
Okay. What's different about these?
Well,
It looks like.
the one on the right is factor, and the one on the left is not factor.
Do I have a common denominator?
Yeah.
Yes.
Yes. You could factor the one on the left.
Okay, so this one's trying to trick us in that x squared plus 3x. If I factor this, GCF of x leaves me with x plus 3. So do I have a common denominator?
Absolutely.
I do already have a common denominator. It was trickery. It looked like we didn't,
Trickery.
but we do. So, okay, common denominator is x plus 3. And you'll always want your denominators factored. Always, always, always. Then on top, it's 2x plus 1, and then minus the 3x minus 8. Okay? Can I just go straight to my answer here?
I mean, you should distribute negative.
Okay, I should distribute my negative. So then I have 2x plus 1 minus 3x and plus 8. All over x plus 3. Okay, what's it clean up as?
Negative x. Negative x. Plus
2x minus 3x, negative x, 1 plus 8, plus 9 over a denominator of x plus 3. Any factoring I can do here?
Nope.
Other than maybe factor a negative 1 out, but I don't think they're going to want that. So I would just leave my answer like that. Are there any excluded values? Restrictions on the variable?
Yeah.
What can x not equal?
X cannot equal 0. X cannot equal negative.
Are there two of them this time? Okay. Denominator equal to 0. So we have factors of x equals 0, x plus 3 equals 0, so x cannot equal 0 or negative 3. Okay? Okay. That's your introduction, guys. Common denominator is already there. Those are the easy type. Now, what do we have to work with? Getting a common denominator. Okay? So that is our next plan. As you look at A in the next section, 3x minus 5 over x squared minus 25 plus 2 over x plus 5. What do you notice? They don't have a common denominator, do they? Thus, we're in the section with unlike denominators. Okay. Your number one thing needs to be factor anything you can with the denominators.
Anything you can with, you know.
Do either of my denominators factor here?
Your x squared does. X squared minus 25.
Okay. X squared minus 25. What's it factor into?
X, and x.
X and x.
Plus 5 minus 5.
Plus 5 minus 5. Okay. Difference of squares, right? Now, the other denominator is just x plus 5. So no factoring there. What we need to find here is our least common denominator. Okay? When we talk about what our least common denominator is going to be,
C, D.
it's going to be, we're going to start by doing anything that's in common between the factors, and then any leftover pieces. Just like you found least common denominators, least common multiples back in elementary and middle school. Same thing, just with variables involved. So, are there any factors in common between my two denominators? There's a what? X plus 5. Since both denominators already have an x plus 5, that's part of my least common denominator. Are there any other leftover pieces I haven't included? Well, there's a leftover piece of x minus 5. Basically, you want to pull any and all factors and put them together in your least common denominator. And that's what we're going to work with here. Kind of like, you know how we added 1/2 plus 2/3 at the beginning of class?
Yeah.
Same idea now. So, I'm going to write this out. My first denominator is already x plus 5 and x minus 5, correct? So it can just stay 3x minus 5. My second fraction only has an x plus 5. What is it missing as the common denominator?
X minus 5.
It's missing an x minus 5. So what we're going to have to do with this fraction is we're going to have to multiply in an x minus 5. If you're going to multiply in an x minus 5 into the denominator, guess what?
Gotta do it to the numerator.
Got to do it to the numerator. So we're going to multiply in an x minus 5 up top. And so when I do this, on top I'm going to have 2 times x minus 5. And on bottom, I'm going to have x plus 5 times x minus 5. So the idea there, now I have a common denominator, right? Look for whatever factors you have, get that common denominator. Now, since I have a common denominator, we can put these together as one fraction, right? Just like on the section above. I have that common denominator. Let's put them together. So my denominator of my answer is going to be x plus 5, x minus 5. And we're going to add those numerators. So I'm going to add 3 3x minus 5 plus, what is 2 times x minus 5? Two times x minus 5 is going to be 2x minus 10. And this should definitely look just like what we did in the upper section, right? Can you finish it off? Common denominator just carries down. X plus 5, x minus 5. Clean up like terms on top. 3x plus 2x is
5x.
5x. Minus 5. Minus 10. Is that right?
Minus 5 minus 10.
Yeah, it is. Okay. I have a mistake in my notes here that I need to fix.
Oh, party foul.
Okay,
I forget who.
so minus 5 minus 10 is going to be minus 15.
Yes, ma'am. X cannot equal 5 or negative 5.
Okay. And I didn't ask you to do restrictions on the variables this time, but yes, I agree. X cannot equal 5 or negative 5.
So we don't have to do it.
Oh,
on
I
the
didn't
voice.
understand that.
It just, in homework, there's only a couple they ask for, so.
So when you're
R,
Good to me.
okay, now, is there anything I can factor in this answer in the numerator?
5x, 5x minus
There is a GCF of 5, and when you factor out a 5 on top, you're left with x minus 3. My denominator has x plus 5 and x minus 5. Does anything cancel?
No.
No. So this is 1. Again, I will take either or. Beware of Savas.
Tonight, guys, when you're doing the homework, just put the factor form in so you don't have to worry about it. Factor form is
Okay.
the money maker.
So, next problem. Where do you think we need to start?
Probably at the bottom.
Look at your denominators and factoring, right? If you don't have a common denominator, you've got to factor and get that common denominator. X squared minus 8x.
That's x plus 4 and egg. No. Oh, wait, you can't just go with that. I'm so stupid. Party foul. That one's on me.
Okay.
That's
guys.
my thing.
X squared minus 8x.
Sorry, guys.
There is a what?
Oh, yeah.
X.
Oh, yeah, there's an X.
There's an X.
On it.
There's a GCF here. Okay, guys, we can't do product and sum or square roots because both terms have x's. So since both terms have x's, we want to think GCF.
Allow me to redeem myself.
So I'm going to factor out the x. What remains when I factor out the x?
You get x minus 8.
X minus 8.
But oh no. There you go.
Now,
I got you.
are you wanting the next one?
I got the next one.
Okay.
Just got
We
it.
also need to factor 2x minus 16. What do you got, Landon?
You're gonna go ahead and you're gonna divide by 2.
Okay.
All right, you got a 2.
What's in my parentheses then?
X minus 8, baby.
Okay. Now, as we talk about least common denominator,
LCD.
Well, what
Okay.
do we do with that X?
first of all, between the two denominators, what's in common already?
X minus
X minus 8.
Okay, there's already an x minus 8. That's going to be part of my common denominator. What are my leftover pieces?
2 and X. X.
There's an x, there's a 2. So my common denominator is 2 times x minus 8, more commonly written as
2X.
2x times x minus 8. Okay. So let's set up our two fractions. Both fractions are going to have what as their denominator when we get done? 2x, x minus 8. 2x, x minus 8. Okay. With that in mind, what is my first fraction missing? My first fraction is missing the 2. So what do I have to do? Multiply by 2. So we're going to be doing 2 times 6x, or in other words, that is
Rats, I wrote it wrong.
12x. Okay, second fraction. What are we missing in the denominator? We've got the 2, we've got the x minus 8, we're missing the x. So what are we doing? Multiplying by x. So in that one, we're going to be multiplying 4 times x.
Oh god, I did this all wrong.
And I don't know why I didn't just go ahead and multiply those out. I kind of wish I had.
Now we have to write the whole thing again.
Wait.
I'm
no, I
done.
didn't do it wrong.
I'm
Yeah.
erasing
Now.
it and just multiplying it out.
Okay, we've got two fractions, same denominator. So we're going to put them together. My common denominator is 2x, x minus 8. 2 times 6x is 12x. 4 times x is 4x.
Oh, I'm
16
So-
next.
You didn't already add.
I'm lost.
Do it now.
Nope.
What is 12x plus 4x?
16x over 2x.
Six.
Let's see.
Is that it?
We're playing it.
Okay, we have,
Yeah, just get that step.
Aaron, have a seat. We have 16x over 2x times x minus 8. The question is there any factoring or canceling that can happen?
I mean, I reckon you could go ahead and
Yeah,
factor out
factor
the denominator there, but you don't do that. It's Friday.
Well, technically, denominator is already factored in that it's 2
Yes,
times x minus 8.
well, yeah, I guess.
That numerator is 16 times x.
Oh my gosh. You can take the X's.
Okay, so 1, I can cancel the x.
Would you get that?
Oh, and then you can
Uh,
some with the 2.
I don't think so.
No, you can't. No.
Hey,
No.
we don't need that negativity over here.
I kind of like what he's saying, something with the 2.
Oh man, you're right. Sorry.
No, there's not a 2 up there, though.
Negative 16.
I'm drawing the
Okay.
line.
Eight?
We have,
16.
Are you talking?
okay guys, let me ask this.
Alright.
Side note.
Okay.
Oh.
What if you had 16 over 2 as a fraction? Would you leave it?
8.
No,
Yes.
Well, it depends. In this case, yes.
What would you leave it and expect to get it right?
Yes.
Yes.
No.
No. What do you know about 16 and 2? They both divide by 2. 16 divided by 2 is
8.
8. 2 divided by 2 is
Oh, so you want us to write it as 8?
1. So my idea here is if we think about reducing or canceling, 2 divided by 2 becomes 1. 16 divided by 2 becomes 8.
Decorated.
So, and this is not an option. If you want credit,
Really?
you would need to reduce the 16 and 2 to be 8 and 1. On top, x disappeared, 16 became 8. We're left with 8.
Over
In the denominator,
minus X minus.
x minus 8.
Yes, ma'am.
I have to ask,
All right, I got a question.
can I cancel those 8s?
Nope.
No, you cannot.
Why not?
Have to the
X
X.
minus.
Okay, this one's an x minus 8. You can only cancel an x minus 8 with this one. Okay, yes, Landon?
Where on earth did we get? Oh, well, never mind.
Well, that's the funny part. The world long. Right?
I'm gonna say the 2 and the X multiplying here, but it kind of makes sense now. I take it back. I withdraw my where on Earth.
Okay. I was all set to answer it too.
We're back on Earth. Well, go ahead. Give me an answer, just in case.
Well, I was waiting for you to finish the question.
I'm
didn't
just going to
put it-
ask where do we get the
Oh,
times the
fucking
x
Molly.
and the times the 2 on the left?
It's already
and
10.
times the on the right.
Okay, well, because when we came up with our common denominator,
Uh-huh.
our common denominator had to be 2x, x minus 8. This denominator is x, x minus 8. So what are we missing
I'm
from
missing the 2. All right.
missing the 2? This one is 2x minus 8. What are we missing? That x.
That makes sense.
Okay, guys.
I don't think we have that.
C.
No, we don't have enough time.
We have time.
Okay.
Do I have a common denominator?
Oh.
Ow!
So what do we do?
Well, that guy down there turns
We're gonna factor.
C.
What do you know about x squared minus 4?
You could probably factor that.
X and x?
That's 4 minus 4.
Try the
I
numbers.
missed you.
Okay. Plus 2 minus 2?
Here's my.
Okay.
You want to share it? I've had enough.
Wait a dog a minute.
Now, x squared minus 5x plus 6. Does that factor?
Yeah,
I'm not.
it's x
Yeah.
minus 2 and x minus 3.
I'll teach you two later.
X and x. Multiplying to be positive 6 means same sign. Adding to be negative 5 means both negatives. So, negative 3, negative 2. Okay, let's talk least common denominator. Start with, what do my denominators have in common?
X minus 2.
So part of my least common denominator is x minus 2.
What about
Okay? Now go for leftovers. What else do we have in those denominators?
X minus 3 and x plus 2.
Okay. I've got x plus 2 in the first fraction and x minus 3 in the second fraction.
those are all?
So what's my common denominator?
That.
All three of those.
Are you kidding?
Okay? Now, both fractions already have 2 of the 3. So that makes it not a horrible thing. But this one is going to require a little work. So let's get moving with it.
Okay. We got points for sleeping. Yeah.
Okay. Denominator in both cases is going to be x minus 2, x plus 2, x minus 3. Plus, I'm going to go ahead and write the next one out. It's going to be x minus 2, x plus 2, x minus 3. If you want to go ahead and put this together as one fraction, you can. Okay, obviously there are ways to shorten up the work here. So I am totally okay with that. Now, in my first fraction, what's missing from my original denominator to get to my common denominator?
Well,
Minus,
X plus 2 is there, x minus 2 is there, we're missing
minus 3.
x minus 3. So that means up here, we're multiplying top and bottom by x minus 3. So we're going to be multiplying x minus 3 by x plus 6.
don't that
Okay.
stay the same there? I reckon it does.
We're actually going to have to multiply it out in the next step. Because in order to add the fractions, we'll need
So
to be able to
FOIL?
put like terms together.
We're foiling.
Now, hold on.
Uh-oh.
Second fraction. I already have x minus 2, x minus 3. What am I missing? X plus 2. So I'm going to multiply top and bottom by x plus 2. You see how I'm deciding what to multiply? So then on top, we've already got a 2. And we're going to multiply by x plus 2. Okay, so there's definitely a little bit of work to do here, guys. Put them together
Well, in terms of
as one fraction. Denominator is x minus 2, x plus 2, x minus 3. The denominators we're going to leave factored the entire time. The numerators, I need to multiply together so I can put my like terms together. Because there's going to be canceling at the end here. We just have to get to it. So, in order to multiply x minus 3 and x plus 6, Landon said it earlier, we are FOILing. So, x squared, outsides, plus 6x. Distribute minus 3. Minus 3x, minus 3 times 6, minus 18. I'll clean that up here in a moment. Plus, because we're adding the other fraction, how do we multiply 2 times x plus 2?
2x plus 4.
Okay, distribute the 2. And it is 2x plus 4. Okay.
Oh my gosh, I get it.
Like terms. Okay, keep the denominator. X minus 2. X plus 2. X minus 3. Numerator cleans up. There's an x squared. What do we have in the way of x's? 6x
6x,
minus 3x.
3x.
So 6x minus 3x is 3x plus 2x
5x.
plus 5x. And negative 18 plus 4,
Negative 14.
negative 14. Okay.
Oh,
There's a chance for simplifying, so what do I need to
x
do?
plus 7 and x minus
Okay.
2. Yep.
Almost there, guys. Denominator stays. X minus 2, x plus 2, and x minus 3. That numerator looks like it should factor, and it does. So, x squared, x and x, multiplying to be 14 is 7 and 2. If they multiply to be negative, I need opposite signs. If they add to be 5, I need plus 7, minus 2. Was it worthy of factoring? Did something cancel?
Yeah, your 2's canceling.
Okay. X minus 2 cancels with x minus 2. Final answer. X plus 7 over x plus 2, x minus 3.
Oh man, those are.
Okay? On Monday, we've got one more to add. We'll practice some subtracting, and we will practice the complex fractions, which you guys are also excited about.
Oh.
I'm jumping out my seat.